Hi, my name's Tom Beach and I was in charge of developing the Accord Digitalisation Methodology. This video is going to describe the Accord Digitalisation Methodology and how we've used it in the Accord project. The Accord Digitalisation Methodology provides a methodology for digitising and formalising regulations and compliance related documents. It builds on top of the AEC 3PO ontology, which provides the underlying semantics for the digitised regulations. It also contains a novel domain-specific language for building compliance-checking documents on top of the AEC 3PO ontology. So who should utilise this methodology? So the main focus of this methodology is regulation experts. We foresee two key users here. We have the users who are regulation experts and they want to digitise their regulations without the need for actually doing the more complex technical things which is commonly outside of their skill set, such as coding. But there's also a role for a second actor here. This is the users that will do the work, such as providing the dictionary of terms, which we'll come on to in just a minute. This figure documents a digitisation methodology. The digitalisation methodology has 5 key phases. The first is the conversion of the document from human readable only into machine readable. Then the next stage is the identification of clauses and the formalisation of logical relationships between those clauses. Then, once you've identified clauses that contain rules, you have to identify the rules within those clauses and formalise the logical relationships between the rules. Finally, you need to formalise the rules themselves, and then you need to map the terms used in the rules to the execution context. And what I mean by this is very commonly the terminology used in regulatory documents does not match the terminology that's used in building models. Now, as you can see from this diagram, we have 3 implementations of this approach here. We have our manual implementation, an NLP implementation, and a hybrid implementation which we're still developing. I'm going to start by discussing the manual implementation. The initial phase of the manual implementation used within Accord is our content extraction. Here, the regulations were manually transformed from flat PDFs into a spreadsheet-based format that could automatically be parsed to provide initial input for the manual digitization methodology. The next step is RASE application. RASE is an approach to digitize regulations by identifying the logical relationships between clauses and terms. So this meets the 2 phases of the methodology, identifying logical clauses and formalizing the relationships between them, and secondly, identifying the individual rules and formalizing the relationships between them. An example of RASE is given below, but first I'm going to explain the concept in more detail. What's really important to understand about RASE is the logical relationship between the tags. What RASE defines is a logical pattern to determine if a given regulation, as in one individual set of text, is true or false. And you can then replicate that en masse throughout the document using boxes. But at the fundamental level, we treat one box and in it we have a set of text and each of those texts has various different colours on it. So the colours in RASE are green for application, blue for requirement, purple for selection and yellow for exception. And what this means is for an individual clause to be true, it must either be meeting all the requirements, not applicable, not selected, or accepted. So this is why we have this OR gate here. So let's treat that one at a time. So if we have a clause that says something like all green doors must be 10 meters wide, then a way for something to pass that regulation is for it not to be a door. If it's not a door, then it's past that. The other way for something to pass that is for it not to be green, because the regulation's only spoken about green doors. The final way to pass that is to be 10 meters wide, because that's the requirement. And that's how RASE works. It's a logical formula that enables you to determine whether an individual piece of text is true or false. Here we have a more detailed example that I'm going to go through with you. And this is a set of RASE tag text that I've added a load of annotations through to individually annotate the result. So as we can see here, we've got one blue box. Inside that blue box, we've got another blue box. And inside that other blue box, we've got another blue box. And we've got a load of text. But we've also got a yellow box. So the first thing we start with the innermost box, which in this case I've labelled BR3. For this box to pass the regulation, we first look at the requirement. It asks us, are there steps on the passageway? So if there's no steps on the passageway, then this passes the regulation. The alternative is there should also be a ramp. So if there are steps on the passageway and there's a ramp, we pass the regulation. But alternatively, if there are steps on the passageway, we could also pass the regulation using the exception, which says there must be a permanently installed device intended for lifting persons. So those are the three ways that we can pass that regulation. And I've written that out here at the bottom logically. So I've said BR3, which is the name of the box, must equal not A3, which is this requirement here, or E1, which is this exception, or R7, which is this requirement. Now, BR2, this next box here, is saying outdoor space may not exceed 5%. So the gradient of a passageway located in an outdoor space may not exceed 5%. So to pass this box, BR2, either the passageway must not be located in an outdoor space, or we must pass the must not exceed 5%, and we must also pass BR3. Hopefully you can see how this all comes together to form a logical pattern. Now you know the basics. In a second, one of my colleagues is going to talk you through a real example.
So we're going to go through a quick example to illustrate the RASE applications across the Finnish regulations. In the fourth clause under the door section, with the sentence beginning with "in connection with the door," this is a particularly good example just because it uses all of the different RASE elements and it's a fairly complex example. You can see by the application of various boxes around each of the elements of the clause, we've kind of already split up this clause into different elements. Initially, we have in the first sentence outside of the yellow boxes a fairly simple overarching application that this clause applies to doors. There is also then a follow-on couple of requirements that there may not be any level difference in connection with the door or any threshold height. So here we've got threshold height equals 0 and a level difference is equal to 0. We have identified, however, in the following sentence, unless this is necessary on account of some other variables, that there are several exceptions to this overarching requirement. We've identified 3 different exceptions to the clause, so we've put in 3 different yellow boxes, and then within each there will be an application and also a requirement. In the first yellow box, it gives a situation in which either a level difference or a threshold may be acceptable where it is necessary on account of noise or humidity or other similar circumstances. So in any of those 3 incidences, we may have some form of level difference or threshold. And then following on from this, it stipulates that in that case, threshold or level difference may not be higher than 20 millimeters, and that all thresholds shall be designed so that they can be easily crossed with a wheelchair or walking frame with wheels. We covered that element, the final element, just with 1 requirement, and for each of the threshold we then have a numerical value to test against of 20 millimeters. In the second element, in the second exception, where we have again a door type that connects with an external space or an outside space, and it is also within an individual dwelling, the level difference outside the door may be again more than 20 millimeters. However, in this instance, it has a follow-on requirement that the level difference can be eliminated with equipment in the outdoor space. Finally, in the last exception, Here we are using a purple tag, which indicates an OR. In either a detached or a semi-detached house, given as a green application, the provisions in the subsections 2 and 3 above only apply to the entrance floor. So here we check that the contained in space exists on floor num 0.
The final step is the rule formalization itself and the mapping to the execution context. The final rule formalization step requires us to undertake expression authoring. This step will formalize the extraction of individual logical decisions. In most cases, these are going to be simple logical operations like width is less than 10. However, to deal with the more complex cases that can and do arise, a simple expression language will be proposed for use. The final step then is bSDD mapping. To do this, we map the terms used in the expression authoring above to the Building Smart Data Dictionary and thus to their equivalents in the IFC. I'm now going to show you an example of a digitized document and just walk through one or two small examples of that. I'm now going to walk you through what an Accord digitized regulation looks behind the scenes. I'm going to purely focus on the first clause of the example that one of my colleagues ran through earlier, and it starts with the phrase in connection with the door. And so what we can see here is in this area here we've got this particular clause which has no logical meaning, it's just text, in connection with the. Then the next thing we've got the word door, but this does have a logical representation that we can see here. Here we have type, an equals comparator, and door. So what we're saying is the type of whatever object this check is about must equal the door. And we have a check statement and an application statement which will illustrate that this is a green coloured RASE. The final thing to mention is the NLP methodology. While there's another more detailed video about the NLP methodology, our NLP implementation in the core consists of 3 stages that we've attempted to automate using NLP: structural segmentation, information extraction, and rule generation. The structural segmentation separates a document automatically into segments or blocks based on the paragraphing and styling in the document. The information extraction focuses on identifying informative text blocks, identifying entities described in these text blocks, and identifying relationships and connections between these entities. And rule generation, the final element here is we'll map information extracted from the text with a rule format to generate the end rules used. Thank you very much for listening. You can access our website with that QR code or follow us on social media.